Hello and welcome. My name is Seb and I will be your personal instructor in this course. I'm a software engineer with 10 years of professional experience and the author of several video courses available on Udemy. This course will test your skills and check your readiness for a developer interview. It contains practice tests and questions that may appear during a technical interview. It allows you to confirm your proficiency and give you the confidence you need to succeed during the recruiting process. The first part of this course will test the fundamentals in a step-by-step and pragmatic way. Then we'll test how to work with various data types, how to control the flow of your programs, how to work with classes, strings, arrays, lists, enums, dates, and file systems. And finally, we will learn how to debug applications. Each practice test has a time limit, and the required grade to pass each test is to achieve at least 80% of correct answers. After completing each test, you can review your answers and look at the explanations for each question. Note that you can take each practical test multiple times, so it doesn't really matter how many mistakes you make. My goal is to help you become an amazing programmer. So I have designed these tests to help you reinforce what you have learned and, most importantly, train your programming brain, which is absolutely crucial if you want to become a successful programmer. If you want to challenge your skills, go ahead and click the enroll button and let's get started. Hello and welcome back. In this section, we are going to look at object-oriented programming. A good understanding of object-oriented programming is important to master the C# programming language. This section provides an insight into object-oriented programming and how to work with it. We'll take a look at the syntax to create a class, how to create an object, how to access fields, and how to modify fields. Any tangible entity is an object. The car, a table, a chair. Object-oriented programming tries to model real-world objects as computer code, hence the name object-oriented programming. It is a set of design principles. It is not a technology. It just provides suggestions to help us design our software. These questions help us describe objects. What is the name of the object? What data do we have about the object? And what actions it can perform? These shapes represent the three questions we have seen previously. We have what is the name of the object, the data we hold about the object, and what actions it can perform. For example, the name of an object, it is car. And what data do we have about the car? We have model, color, and weight, as you can see over here. And what actions can the car perform? We can power on the car, we can shut down, and we can activate the wipers, among many things. Now, the data we have about the object is stored in a class. A class is like a blueprint or a factory that describes all the details of the object. It is used for creating as many objects as we need. So to summarize, an object is the creation of a class. It inherits all the data and methods from a class. With one class, we can create an infinite amount of objects. So using this class over here, this class called car, we have created one object car, the second one over here, the third one over here, and the fourth one over here. And they will all contain all the data we have about the object. So they will all have the same data describing the object, and they will all perform the same action. An application is made up of many different classes. Some contains hundreds or even thousands of classes. Each class is responsible for a small section of the application, and when combined, they create complex applications. So in this particular example, we have 6 classes that combine to make one application. Alright, now let's take a look at how to create a class in C#. So as we have seen previously, a class is a group of related methods and variables. Let's create a class called smartphone. It is good practice to start the class name with uppercase letter. That's why the S is in uppercase. And to create a class, we need the keyword class. And all the codes that belong to this class will be between these curly brackets. One of the most basic building blocks of a class is a field. When we declare a variable inside a class, it is commonly referred to as a field or attribute. They are like global variables for a class. So for our class that we have declared previously, smartphone, we have declared 3 fields. These fields will describe the objects we create from this class. So we have two string type and one integer type, color, weight, and model, and we have assigned some temporary values to it. So all the objects we create from this class will contain these fields and these values. Alright, now let's take a look at how we can create an object. Previously, we have seen that an object is created from a class. Since we have already created the class called smartphone, now we can use this class to generate objects. Creating objects is pretty easy. We just specify the class name. So in this case, it is smartphone. Then we type in the object name, which is my smartphone, and followed by the equal sign, the new keyword, and we type in the name of the class again. And finally, we have the rounded bracket and a semicolon to end the statement. So that was pretty quick and relatively easy. Now let's take a look at the main advantage of using object-oriented programming. Like puzzle pieces, classes collaborate with each other to create complex applications. Object-oriented programming allows us to plug and play features to our application. We can add new features and control their effect on other parts of our application. So that's it for this section. Hopefully you have learned quite a few things about object-oriented programming. If you have any questions, just type them in the comment section below, and subscribe to our YouTube channel for live stream and live Q&A, among other things. So see you guys later. Goodbye. Hello and welcome back. In this lecture, we'll take a look at the solid principles. We'll look at what are the solid principles, what are the common software issues, and what are the advantages of the solid principles. So what is the solid principle? Solid is an acronym for 5 design principles, mainly single responsibility, open closed, list scope substitution, interface segregation, and dependency inversion principles. Solid refers to golden rules used by object-oriented developers for crafting reliable, understandable, flexible, and maintainable software. Solid practitioners swiftly handle most of the software design problems they encounter in their daily programming workflow. Whether it is designing or coding an application, we can leverage the advantages of solid principles to write clean code. This lecture provides you with a hands-on approach to learning the solid principles. In the late 1990s, computer scientist and instructor Robert C. Martin, also known as Uncle Bob, popularized these principles through his numerous books. Uncle Bob is the author of many New York Times best-selling books such as Clean Code, Clean Architecture, Agile Software Development, Principles, Patterns, and Practices. These principles quickly became a staple of modern object-oriented design. So here he is in 2020 in his home office, surrounded by the most classic computers throughout history. Alright, now let's take a look at the software development lifecycle. Our natural tendency is to start coding application based on our experience and knowledge right away. However, over time, as applications are altered for new features requests or simply bug corrections, if the application was not designed with maintainability in mind, then even for simple tasks we have to put in too much effort with massive reworks and testing. New feature requests or bug fixes should not be blamed. They are part of the software development lifecycle. We can't stop them, and it is our job to fulfill them. And the only thing we can control is the design of the application. We should really strive to make the system design as clean and scalable as possible. That's where the famous solid design principles come in handy. It helps developers eliminate common design issues and how to build the best possible designs. Alright, now let's take a look at some of the common software issues. Classes with too many responsibilities assigned to them are hard to debug, and tight coupling between classes, which makes adding new features a challenge. And finally, there is lots of code duplication. So what are some of the common solutions to the common problems? Choosing the appropriate clean architecture such as MVC or Onion, among others, will really reduce the number of software issues. And as we will cover in this lecture, the solid principle will also reduce the number of issues, and also design patterns, which are solutions to common software problems. Alright, now let's take a look at some of the advantages of solid principles. Solid helps us achieve maintainability, testability, flexibility, and agile development when developing softwares. Now let's take a look at maintainability. As a business expands, there is a growing need to enhance the existing software. A well-crafted software accepts future changes with minimal effort and doesn't inject new bugs. Now let's take a look at testability. Loosely coupled applications facilitates testing of each functionality. Solid Principles also encourages test-driven development, which we will take a look at in other lectures. And Solid also encourages flexibility. A flexible software means software design is adaptable to future modifications with ease, and it is also extensible when adding new features. Now let's take a look at agile development. Dividing a software into various components allows many teams to work independently and simultaneously on the project. This not only saves an enormous amount of time, but also reduces the cost during software development. So throughout the years of programming, I've realized that it's really tricky to change the code structure if you don't apply the solid principles and other coding standards. So clear, understandable, loosely coupled, and scalable are important software attributes we should really strive for. Hopefully this lecture inspires you to apply the solid principles while developing application. It will deepen your experience in creating the most beautiful code base. So in this lecture, we have covered what are the solid principles. We have looked at the common software issues and how solid help us prevent these issues. And finally, we have looked at some of the advantages of solid principles. So that's it for this lecture. If you have any questions, just type them in the comment section below. So see you guys in the next lecture. Goodbye. Hello and welcome back. In this lecture, we'll take a look at the open-close principle. We'll explore what is the open-close principle, what are the implementation approach to achieve the open-close principle, what is the advantages of this principle, and some of the implementation guidelines for this principle. The letter O in SOLID stands for open-close principles. This principle advocates that software entities such as modules, classes, functions should be open for extensions but closed for modification. Open for extension means with new requirements, we extend the software entity with new behaviors, and closed for modification means we should not modify existing code except for bug fixing because the source code has already been tested, so modification can affect other existing functionalities. So let's take a look at our first demo. Let's say we need to calculate the transaction fee when using each type of card. For example, we have Visa, MasterCard, and American Express and Discover, and each one will charge the client a different transaction fee. So we need the system to calculate that fee given a specific amount. So we have the class fee calculator. We have a method called get transaction fee. We take in the amount of money. We need to calculate the transaction fee, and then the type of card, which is an enum. And depending on the type of card, whether it is Visa, MasterCard, American Express, and so on, they each have a percentage, for example, 0.01, 0.5, 0.1, 0.02. We'll multiply that amount, and that will be our transaction fee. And over here inside our main method, we instantiate the fee calculator class, and we use that object to get the transaction fee for $270, and the type is Visa and American Express. And finally, our output is 13.5 and 27. This software works, but to extend it, we will have many difficulties. All right, now let's take a look at some of the problems we will encounter with this design. So adding new features requires testing the existing application as well as the new features. And this program also violates the single responsibility principle as the software entity performs multiple jobs. And also implementing all the features in one class makes maintenance of the class very laborious. So these are some of the issues we encounter using our previous design. Let's take a look at how we can improve that. So we can improve it using inheritance. Derived classes inherit all the base class code is a good way to implement open clause principle. Another way is through abstraction. So either the abstract class or interface so that the implementing class can be switched dynamically with minimal impact. And other ways are parameters and composition/injection. So in this demo, we'll take a look at how we can improve the open close principle using abstraction. So let's say we need to add another card. We need to modify this enum and we need to add some condition inside this class. So these are bad implementation. When we need to modify code in different places, then we know it is a bad design. So this class will need to be retested and maintenance will be much harder. And this class also breaks the single responsibility principle. So adding a new card requires additional testing. And let's take a look at how we can improve this design using abstraction. So instead of an enum, we type in a new interface called iCardType. Then we have the method definition called getTransactionFee, which takes in the amount we need to calculate the transaction fee. Remember that an interface is a contract. So we are compelled to implement this method. So over here we have the different classes representing the different cards. So MasterCard, Visa, and American Express. They will each implement the iCard interface. So they are compelled to implement this method getTransactionFee, as you can see over here. And inside the different classes, we can type in the different amount to calculate. So for Visa, it is .01, .05, and .1 for American Express. So let's say in the future, we have to change the transaction fee calculation. So we just need to modify this class. This will not be impacted. This one will not be impacted. And this interface will not be impacted. So when we need to change the transaction fee, we just need to implement it inside one class. So this type of design encourages loose coupling and high cohesion, which is the desired result for any design. And over here inside our main method, we instantiate the Visa class, the MasterCard, and the American Express. And then we call the method getTransactionFee for each one. And we input our amount, which is 270. And finally, inside our console, we have the desired output. So we have the exact same output as before. However, now we have loose coupling and high cohesion inside our design, which gives us more flexibility than before. Alright, let's take a look at some of the advantages of the open close principle. So code maintenance is way easier as it reduces the risk of breaking the existing implementation. Instead of reworking the base class to fit a new requirement, we just create a derived class separate from the existing classes. So now we have confidence that the new changes will not affect the parent or any other derived class. So we don't need to redeploy our code. We don't need to retest all the classes and its functions because the new changes will not affect the parent or any other derived class. Another way to achieve the open close principle is through parameters. So over here we have the class mail sender. So this is a simplified version of sending mail. We just print the email sent statement. However, let's say in the future, we want to change this text. Instead of email sent, we want to print the date and time that we sent the mail. So we need to come inside this class and modify it later. Let's take a look at how we can improve this design so that it is open for extension, but closed for modification. So using parameters, we just create a variable of type string, and then we use that variable to print it, and the console.writeLine statement to print the text inside our console. So over here, we just instantiate the class, and then we call the method sendMail, and we can type it any text we want over here, and it will be printed inside our console. So next time we need to change that text, we just call it over here. We do not need to modify this class. We just change the text over here. Another approach to implement the open close principles is inheritance and method overriding. So we have the class vehicle and we have the class car. We use the colon which denotes inheritance. So we are inheriting this class with all its methods and fields. However, using the override and virtual keyword, we can override the implementation of this class. So we do not need to modify this class. We can override its implementation inside the child class. So in this way, this class is closed for modification, but open for extension. And we can customize the implementation of the activate wiper over here. So instead of generic wiper activated, we will call it car wiper activated. And inside our main method, we instantiate the class vehicle and the class car. And when we call the method, as you can see, we have two implementation. We have the generic wiper activated, which is called, and the car wiper, which is our customized implementation of this method. So to summarize, this class is closed for modification and it is open for extension using inheritance. So don't be afraid to create new classes to implement new features. It allows us to add new behavior without touching the existing code. So we do not need to test the existing code, and we can code with confidence that our new features will not impact the current features. This also encourages the single responsibility principle because each feature will be developed inside a new class. And finally, new classes can be easily unit tested. This advocates the test-driven development. So now let's take a look at some of the steps when implementing the open-close principle. So at first, just implement the solution using concrete code. Secondly, try to brainstorm with your team all the future requirements and new features that you will need to add. Then modify the code to be extensible without modifying the source each time. So try to come up with solutions to make the application extensible, whether through abstraction, inheritance, method parameters, or composition and injection. However, beware that using too much abstraction also adds complexity to the code. So try to find the right balance between abstraction and concrete implementation. So to summarize, we can apply the open-close principle by using interface, abstract class, abstract method, and virtual method to extend the functionality of our current software. So it is possible to implement both open-close principle and single responsibility principle, as each class has a single task to do, and we are not modifying the class and only doing the extension. So by implementing our solutions this way, it works well for close modification, as those methods are implemented and managed in their own classes. So each time you have a new type of code, for example XYZ, that needs to be added, then we add it inside a new class. As a result, the current functionalities that have already been implemented are going to be unchanged. The main advantage of this approach is that we just need to test and check the current new class. So that's it for this lecture. Hopefully you have learned quite a few things about the open-close principle. If you have any questions, just start them in the comment section below. So see you guys in the next lecture. Goodbye. Hello and welcome back. In this lecture, we're going to cover the interface segregation principle. We'll take a look at what is an interface, what is the interface segregation principle, some of the common ways there is violations of this principle, and finally we'll conclude this lecture by taking a look at some of the advantages of this principle. To understand the interface segregation principle, we first need to understand what is an interface. In C#, an interface helps us to achieve data abstraction, and it can be seen as a contract for classes to implement all the method definitions. And by default, all the interface members are abstract and public, so we do not need to specify these keywords. So over here we have the interface called iRobot, and notice the method definition shutdown and boot up sound. So they are just method definition. There are no implementation code. It's the job of the subclasses to implement all these method definitions. So how do we implement an interface? So over here we have an interface iRobot with the method definition boot up sound, and over here we have the class industrial robot, and notice the colon, which signifies that we are implementing this interface, and we need to provide the implementation for this method definition. So over here, to simplify things, we are just going to print console.writeLine I am ready to rock and roll, and inside our client class, which is called program, and inside our main method, which is the entry point for the application, we instantiate the class industrial robot and we call the method. And as you can see over here inside the console, we have successfully implemented the interface and call this method. Alright, now let's take a look at some of the common mistakes when working with interfaces. So remember that an interface, it is a contract. So when a class implements that interface, we have to define all the method definition. We need to implement all the method specified inside that interface. Otherwise, we will get an error. As you can see over here, it is underlined in red, and the compiler says the industrial robot does not implement interface member boot up sound. So remember that an interface is a contract. We need to respect that contract and implement all the method definition inside the interface. And finally, now let's take a look at the interface segregation principle. The letter I in the solid design stands for interface segregation principle. This principle recommends that classes do not include behaviors they do not use. So in other words, instead of a multi-purpose interface, it is better to have multiple smaller ones. That's because just like regular classes, each interface should have a specific responsibility. A large interface increases the likelihood it includes methods that are not necessary. So we should prioritize role interfaces over header interfaces. Each interface should have a specific responsibility. Alright, now let's take a look at some code that violates this principle. So over here we have an interface called iRobot. We have two definitions, BootUp and Start AI Assistant. We have the industrial robot class which implements this interface, as you can see over here. And we have implemented this method BootUp sound. We have a simple console.writeLine statement. And over here, notice for the Start AI Assistant, we throw a not implemented exception. That's because this class industrial robot is forced to implement this interface. However, this method is not useful for us. That's why we have to throw a not implemented exception. So to summarize, we need to implement these methods. However, this one is not useful for us. So we need to throw a not implemented exception. So over here, we instantiate the class industrial robot, and then we call the BootUp sound, which displays I am ready to rock and roll. We have the exact same output. However, this code violates the interface segregation principle because we are forcing this class to implement the Start AI method, but it doesn't need it. Alright, now let's take a look at some of the issues when we force a class to implement methods it does not need. The first issue is we increase the dependency between the different classes. So there is more coupling, which makes the code more brittle, and we need to have more testing. And another issue is that this approach reduces the flexibility when adding new features, but also when maintaining the existing code. Alright, now let's take a look at some of the common red flags that indicate we have violated this principle. Usually large interfaces will force all the classes to implement all of its method definition, so that could be a red flag. Instead, you should prefer smaller interfaces. And if you're using too much not implemented exception, then this is probably a sign that we are violating this interface segregation principle. So usually when you see classes implement a small section of an interface and uses this exception, this not implemented exception for the remaining method definition, then this probably shows we are violating this principle. Let's take a look at how we can fix these issues, how we can fix the code that violate the interface segregation principle. So first off, let's break all the large interfaces into smaller ones. We should not try to control the large interfaces with exceptions. And finally, another common way is to use the adapter design pattern, which we will cover in later sections. So over here we have two interfaces. We have one iRobot with method definition BootUp sound, and we have another interface called iArtificial Intelligence, and it has the second method definition. And when we have the class industrial robot, notice it implements only one interface over here, and since this class only needs this method definition, it can implement only that method. So over here, to simplify things, we have the console.writeLine statement. So that's how we try to fix the code that violates the interface segregation principle. We just break up the large interfaces into smaller ones so that we do not force that class to implement methods it does not need. So we can break up a large interface into multiple interfaces because C# allows us to implement multiple interfaces. So over here we have interface 1, which is called iRobot, and we have interface 2, which is artificial intelligence. And over here, notice we have the class industrial robot, and it implements the iRobot and the artificial intelligence interface because we have used the comma. So in C# you can implement as many interfaces as you want as long as you separate the interface name with commas. So implementing multiple interface means we have to implement all the method definition that is inside the interfaces. So over here we have the BootUp sound, the body for BootUp sound, and we have the body for Start AI Assistant. And as always, to simplify things, we have put just the console.writeLine statement. Inside the client code, which is program, we instantiate the class industrial robot, and we can call the BootUp sound and Start AI Assistant. And as you can can see over here inside the console, we have successfully implemented the interfaces and called them. Another tool to help us break large interfaces into smaller ones and adhere to the interface segregation principle is inheritance of interfaces. So over here we have interface 1, which is called iRobot, and we have interface 2, which is called artificial intelligence. And notice we inherit all the method definition using the colon of the first interface iRobot. So now this artificial intelligence interface contains the definition for start AI assistant and the boot up sound method definition. And we have a third interface called augmented reality mode, which inherits all the method definition inside the artificial intelligence. So the augmented reality mode will contain this one, the start sensors method definition, and it will also contain the start AI assistant and the boot up sound method definition. So when a class implements this augmented reality mode, it will need to implement all these method definition. So inheritance is another tool to help us adhere to the interface segregation principle. All right, now let's take a look at some of the advantages of interface and adhering to the interface segregation principle. So first off, when we use interfaces, it helps us achieve abstraction, which increases the application security by showing the most essential detail of an object through the interface. And in C#, we have the tools to implement multiple interfaces, with each interface having one specific responsibility. And to implement multiple interfaces, you just use the comma separated, then we type in the name for the next interface. Above all, an interface is like a contract. It forces the class to implement all the methods. This is to ensure cohesion between the classes and the different parts of the application. So that's it for this lecture. We have covered what is an interface, what is the interface segregation principle, some of the common interface segregation principle violations, and finally we have looked at some of the advantages of interfaces and the interface segregation principle. So that's it for this lecture. If you have any questions, just type them in the comment section below. See you guys in the next one. Goodbye. Hello and welcome back. In this lecture, we'll explore the single responsibility principle. We'll take a look at what is the single responsibility principle, the common software issues it solves, and we'll take a look at Tudemo, the forum registration system, and the attendance system. And finally, we conclude this lecture by taking a look at some of the advantages of single responsibility principle. The letter S in SOLID stands for single responsibility principle. It recommends that every software module, class, structure, or methods should accomplish only one job. Hence, they will have only one reason to change. These modules should not multitask like a Swiss knife. Just because we can put every single line of code in a single class doesn't mean we should. Otherwise, if one of the classes needs to be changed, then the entire software needs to be modified. This reduces the number of reasons to modify a class. Classes usually work together to accomplish complex tasks, but each class must accomplish only one job from start to finish. Consequently, classes are smaller, contains cleaner code, and thus easier to maintain. So to summarize, a responsibility means a reason to change the code. More responsibility means multiple reasons to change the code. And we take a look at hook cohesion and coupling, which is often used when describing single responsibility. So cohesion means how strongly related the various responsibilities of modules are. And coupling means the degree to which each module relies on other modules. So we should really strive for low coupling and high cohesion. So let's take a look at a common example. So the refrigerator contains mostly consumable items, such as over here we have the cheese, eggs, water, lettuce, and meat. So you wouldn't put your cleaning equipment inside the refrigerator, right? Or your repair tools, such as hammer, drilling tools, and paintbrush. So they do not belong inside the refrigerator. So all the items inside the refrigerator have high cohesion, so they are strongly related to each other. So it has high cohesion, which means how strongly related the various responsibility of a module. So they are highly related, and coupling means the degree to which each module relies on other modules. So there is low coupling because they are not reliant on these consumable items inside the refrigerator. So we have separated, in other words, we have decoupled the items from each other. Over here we have the consumables, over here we have the cleaning equipment, and over here we have the repair tools. So we have decoupled the items, and there is high cohesion between the groups because all of these are cleaning items, all of these are repair items, so there is high cohesion. They are strongly related to each other. So that's the difference between low coupling and high cohesion. All right, now let's take a look at our first demo, which is the attendance system. So we have the class attendance system. We have the method main, which is our entry point. We have the method add attendance, delete attendance, send attendance email, and log information. So login information will just log what time and date we have added or deleted the attendance, and this method will just simulate how we send an email after adding or deleting attendance. So the problem of such a class, it does too many things. It has too many responsibilities. If we write the database logic, the business logic, and the display logic in a single class, then the class is performing too many responsibilities. So by mixing multiple responsibility inside one class, we are violating the single responsibility principle. So now let's refactor this so that every class is responsible for one functionality. So over here we have grouped one class. We have the add attendance and delete attendance, which we group inside one class, and the logging system, which is not highly related to this one. Although it will be used inside the attendance system, it is not necessary to have it implemented inside this class. So we will separate also the mailing system. So we will have one class, two class, and three class. So let's say currently we are saving all our data inside an MS SQL Server database. Let's say we want to change it to Oracle. So we just need to edit this class. It will not affect this one or this one. They can use the login system, but we only have one place to edit that code. And let's say we need to modify how we send the email. So we just need to edit this class. This one will not be affected. It will just use this class, but it is not implemented over here. It will be implemented over here. Now let's take a look at some of the problems we encounter when a class has too many responsibilities. So first, it will be difficult to maintain and understand since there will be too much code inside one class. It will be hard to track all the changes. Another problem is with testing. It will be difficult to test all the functionality because they are highly concentrated in one class. There is too much coupling inside that class. So changing one section inside the class will affect other section inside the class. So that is not good for maintenance. And there is a high probability of code duplication because the one class will do so many functionalities. It will have too many responsibilities. All right, now let's take a look at how we can improve our design to decouple the application. So we have the class 1, which is attendance system. We have the second class mail sender, and the third class, which is called logger. So to simplify, we are just going to print the email sent and information logged inside database. To have a simplified example, it will have the method send email attendance and log information. And notice over here we have two fields. We have the underscore logger and underscore mail sender. They will reference the classes. So we will be using the mail sender and logger inside the attendance system. However, because they are inside a different class, we can choose how we want to implement this and how we want to implement this, and it will not affect the main class. This class will just use these two classes without knowing how they are implemented. And over here we instantiate a new object of that class mail sender and object for logger. And over here we have the add attendance, which will just print new attendance added. It will send the email and log that information. And over here for delete attendance, we will just display attendance deleted and simulate the email sending system and login information. So over here inside the program, which is our client, we just instantiate the attendance class, and using that object we will call the add attendance method. And as expected, it will display new attendance added, email sent, and log information. So notice we have the exact same output as before. However, we have decoupled our application so that any change in this class will not affect the attendance class, and any changes inside the logger class, we can change the implementation of the logger class and it will not affect the attendance class, because the attendance class is just using the functionality. It doesn't implement the logger or the main sender inside this class. So that's how we create loosely coupled but high cohesion classes and applications. Alright, now let's take a look at our second system, which is the forum registration system. So the system will be able to validate user data. So the user will input their data inside the system and we will validate that data. We will save that record and we will allow the user to import their profile or any other picture, and we will send a confirmation mail. And to simplify the system, we will just print a console.writeLine statement. So record saved, email sent, and so on. Notice that we just have one class. It is called user registration, and inside the main method we will call all the functionality, which is validate, save, and mail sender. So the problem with this class is that it handles too many things. There is too much coupling inside this class and there is low cohesion. So remember that for good object-oriented design, we need to have high cohesion and low coupling. So let's take a look at how we will split the system into multiple classes. So our first class will validate the user information and save that record. And of course, we can subdivide this into multiple classes, but to simplify this system, we will just create 1, 2, and 3 classes. So let's take a look at that sample application in practice. So we will have one class which is called forum registration. We have our second class called mail sender, and the validated class which will validate the user input, which is class 3, and we will have a class 4 to store the data of the user. To simplify things, we will just display and store the username of the user. So over here we have the constructor which will just save that input inside the private field, and we have the property username. So notice inside the main class we have a reference to the mail sender. So over here we will reference the mail sender and we will reference the validator. So any changes of how we implement the validator will not affect the implementation of the forum registration. The forum registration, we just use that class, so it will not be affected. However, to validate the user using a different regular expression, so that will not be impacted inside the forum registration class. Again, over here, let's say we want to change the way we send an email. It will not be reflected inside the forum registration, so we can implement it however we want. We just use it over here. So we create an object of type mail sender and validator so that we can use it, and inside the register user we will use the validator and send email, and to simplify things we will just print user registered. Alright, now let's take a look at how we can use all that code to register a user. So we will instantiate an object of type user. We will input the Ben username, and we will instantiate the forum registration class. And forum registration dot user register user, we will input that user Ben inside that class, and over here we have the output. We have username Ben is valid, so the username the user has type is valid. It doesn't contain any invalid characters, and we have successfully registered the user and we have sent a confirmation mail to the user. So that's how we create high cohesion and loosely coupled applications. We just divide the application into multiple classes and make sure all the method inside that class have high cohesion. They are strongly related to each other. Otherwise, just split it inside another class. So what are some of the advantages of single responsibility principle? In other words, what are some of the advantages of high cohesion and low coupling applications? So first, the single responsibility principle helps us identify all the ways a class can change. A class with only one responsibility is likely to be very robust and easy to bug. If a single functionality breaks, we know in which class the bug will be, and the classes will be much easier to understand for newcomers and implement than the ones that multitask. And we can also change the behavior of a function by editing a single class responsible for it instead of editing multiple classes, which can trigger a domino effect inside our application. So we have covered what is single responsibility principle. We'll have looked at some of the common software issues, and we have looked at 2 demos, mainly forum user registration and user attendance system. And finally, we have concluded this lecture by taking a look at some of the advantages of single responsibility principle. So that's it for this lecture. If you have any questions, just type them in the comment section below. So see you guys in the next lecture. Goodbye. Hello and welcome back. In this video, we're going to explore the last solid principle, which is the dependency inversion principle. We'll take a look at what is the dependency inversion principle, what is abstraction. We'll take a look at the new is glue concept, and finally we end this lecture by taking a look at how to implement an interface and the advantages of the dependency inversion principle. So the letter D in solid stands for the dependency inversion principle. The fifth and final principle is all about dependencies among components. This principle is divided into 2 sections. We have the part 1 advocates that upper level modules should not be dependent on lower level modules. Instead, both should depend upon abstraction. The upper level modules includes business models, and if these modules depend upon the lower level details, then modification to the lower level modules directly impacts the higher level ones. This triggers a domino effect, forcing the upper level to change in turn. This tight coupling raises the risk that modifying one class will break other classes. So we need to make sure that both the upper level and the lower level modules depend upon abstraction instead of knowing about each other. And the part 2 of this principle advocates that abstraction should not depend on concrete implementation. Instead, concrete implementation should depend upon abstraction. So this dependency inversion principle places a heavy focus on abstraction. So we'll take a look at that first. So what is abstraction? Data abstraction is the process of showing only the crucial data. For example, we can use a smartphone or apply the brakes in a car without knowing how the electronic circuits work internally. So some of the ways to achieve abstractions are abstract classes over here, and the second way is through interfaces. So why is abstraction so important? That's because the new keyword, which is used to instantiate new objects, glues the code to a particular implementation. In other words, we are kind of hard coding the application to work with one particular class implementation. Instead, we should be using abstraction to decouple the application, which in turn makes the application easier to modify and maintain. Alright, now let's take a look at what is an interface. As we have seen previously, an interface is a way to achieve data abstraction, and an interface is just a contract for classes to implement, meaning when a class decides to implement an interface, it needs to implement all its method definition. And by default, all the interface members are abstract and public, meaning we do not need to type the abstract keyword or the public keyword. Now let's take a look at how we can declare an interface. So over here we have an interface called iRobot, and notice we have 2 method definition called shutdown and boot up sound. Notice there is no curly brackets, meaning they do not have any implementation code. It's the job of the subclasses to implement these methods. So how do we implement an interface? So over here we have the interface called iRobot, and we have the class industrial robot. Notice we use the colon to signify that this class is implementing this interface over here, and we have a method definition called boot up sound. Since the interface is a contract, we need to implement this method. So to simplify things, we are just going to put in a console statement, console.writeLine, I am ready to rock and roll. So that's how we implement an interface. And inside our client code, which contains the main method, we instantiate the class industrial robot, and we call up the method boot up sound. And as you can see over here inside the console, everything is working perfectly since the message is printed inside the console. So that's how we implement an interface. We make the class extend that interface, and we provide the implementation for the method definition found inside that interface. So to appreciate the advantages of using the dependency inversion principle, first let's take a look at some code that does not apply this principle. So over here we have a class called salary calculator. Let's say we need to develop a system to find the salary for each employee. So over here we have a method called calculate salary, and it takes two parameters, namely the hours worked and the hourly rate. And to get the salary, we just multiply the hours worked and multiply it by the hourly rate. That's how we calculate the salary for an employee. Now, to simplify things, we are just going to store the minimum details for an employee. Namely, we have a property for the name, the hour worked, and the hourly rate. And inside that employee class, we have a method called getEmployee, and we are going to reference this salary calculator over here. We'll instantiate an object of type salary calculator is equal to new salary calculator, and we're going to call the calculate salary over here, and we'll use the properties hours worked and the property hourly rate. Now let's take a look at the main method. So we have the client code inside the program class, and we have the entry point for the application. And inside that main method, we instantiate an object of type employee, which we have defined previously. And we are going to assign the properties name, hourly rate to some values. So in this case, it is Rohit Kumar, the hourly rate 131 and 160. And we are just going to display the salary for Rohit Kumar inside the console. And as you can see, our code is working perfectly. We have multiplied 131 and 160. The result is 20,960. That's the salary for Rohit Kumar. Now, the problem with this implementation is that over here inside the main employee class, we are using the concrete implementation of salary calculator. So using the new keyword over here, we are gluing our code to this particular implementation. We are permanently hard coding this application to work with the calculator 2022. Now let's say in 2023, HR wants to develop a new formula to calculate the salary. Then we need to come over here and modify the employee class. This is not a good strategy because if we modify this class, we are violating the open close principle, which states that a class should be open for extension but closed for modification. Now, why is it closed for modification? It's because when you modify a code, you have to retest everything to make sure we did not inject any new bug. Obviously, that is not a good strategy. And some other classes might be dependent on the employee class. If you modify over here, it might cause a domino effect and insert some bugs in other parts of the application. So currently, the employee class is directly dependent of the salary calculator. So that is not a good strategy. Instead, if we make the employee class dependent on abstraction, in this case, it is an interface called iSalaryCalculator, and we make that salary calculator interface link to the salary calculator 2022. And let's say next year, 2023, HR comes up with a new formula. Then we just change the link from the interface. We point it to the salary calculator 2023, and we did not modify the employee class, and we do not need to modify the class salary calculator. We just create a new class with the new implementation and point it to the new interface. So let's take a look at how we can change that code to respect the dependency inversion principle. So we have the interface called iSalaryCalculator. We have the method definition for calculate salary. It takes two parameters, hours worked and hourly rate, just like before. And we have our class salary calculator 2022. And notice that now it implements the interface salary calculator. So implementing an interface means we need to implement the method definition. So over here we provide the implementation, calculate salary. We take in two parameters just like before, hourly rate and hours worked, and we return the hours worked multiplied by hourly rate. Now let's take a look at our employee class. over here, instead of referencing to the calculator 2022, we are referencing the iSalary calculator interface. We have our 3 properties, and notice over here something new. We have the constructor, and we are injecting a reference to that interface iSalary calculator and to initialize our private variable over here. And we have the getSalary method just like before. However, now we return the reference to that interface and we call the calculate salary method, and we pass in the properties as arguments. So this hours work property goes over here and the hourly rate goes over here. So now notice that we instantiate an object of type employee, and over here we inject the concrete implementation. So we have removed the instantiation of the calculate salary clause from the employee clause, and we have put it inside the client code, which is the main method. Then we assign the values to the properties as before. We have Rohit Kumar 131 and 160, and we just print the salary for Rohit Kumar. And as previously, we have the exact same output. However, now our employee clause is not dependent on the salary calculator 2022. Instead, it is dependent on the abstraction, or in this case it is the interface. So iSalary calculator interface is the abstraction layer and the employee class is the higher level module. So in this example, salary is completely decoupled from the employee class using the iSalary calculator interface. The object is injected inside the constructor of the employee class in reference to the interface iSalary calculator. The constructor where the object gets injected is called the injection constructor. So this is called the injection constructor, which allows us to develop loosely coupled code. We can reduce type coupling between the software components. It also allows us to better accomplish future changes and help with the maintenance by making our code more sustainable. So we are not dependent on the salary calculator class. Instead, we are dependent on the interface. Let's say HR comes up with a new formula. We just create a new class called salary calculator 2023 and we put it over here. We are not modifying the employee class. We are injecting it through the constructor. So what are some of the advantages of using interface and applying the dependency inversion principle? Abstraction increases the application security by showing the most essential detail of an object through the interface. Above all, an interface acts as a contract which forces the classes to implement all the method definition found inside that interface. And another tool to help us with dependency inversion is that C# allows us to implement multiple interfaces with each interface separated with a comma. So there is no limit how many interfaces you can implement. So in this lecture, we have covered what is dependency inversion principle, what is abstraction. We have looked at the concept of new is glue, how to implement an interface, and we have covered the advantages of dependency inversion principle. So that's it for this lecture. If you have any questions, just type them in the comment section below. So that's it, guys. Hopefully you have learned quite a few things about the dependency inversion principle. So see you guys in the next lecture. Goodbye.